Hello, welcome to my channel. We have been solving this past exam papers. So you can see it is from May, June 2025, and it is mathematics, pure mathematics one. Okay, so we already did question 1 to 5. So today we will be doing question number 6. 3, 4, 5, and yeah, this is what we are going to do. Okay, the equation of a curve is this, and the equation of a line is this, where this k is not known right now, and this p is not known right now. Okay, now if k is 2 and p is 11, find the coordinates of the points of intersection of the curve and the line. Okay, if k is 2, this parabola will become 2x squared minus 2xy plus 2 equals 0. I'm not sure it's parabola, but maybe, yeah. Anyway, and the second curve is y equals, and p is 11, 11x plus 3. So this is a straight line. Okay, in order to find the point of intersection, I will just replace this y by this value. So it is going to be 2x squared minus 2x into y is 11x plus 3 and plus 2 equals 0. So let's simplify this. 2x squared minus 22x squared, and this is plus 3. So minus plus minus 6x plus 2 equals 0. So 2x minus 22x is minus 20x squared minus 6x plus 2 equals 0. So let me divide everything by minus 2. So it will become 10x squared plus 3x and minus 1, right? And let's solve it by using quadratic formula. So x equal minus b plus minus under the root b square minus 4, a is 10 and c is minus 1. So divided by 2a, this is 20. And when we solve this thing using calculator, I got two answers, 0.2 and minus 0.5. Okay, so now we need to find the y coordinates. So if x is 0.2, you can see from this expression, y is equal to 11 into 0.2 plus 3, and this will give us, where did I find those values? Now, if x is 0.2, the y comes out to be 5.2, and if x is minus 0.5, then y would be 11 into minus 0.5 plus 3, and it will give us minus 2.5. So point of intersections are 0.2 and 5.2. This is one point, and the second point is minus 0.5 and minus 2.5. So these are the 2 points of intersection of these two curves. Okay, now let's move on to second part of this problem. It is given, instead that p is 4, find the set of values of k for which the curve and the line do not intersect. Okay, so p is 4 this time. So the straight line is y is equal to, the straight line is y equals to 4x plus 3, am I right? Yeah. And the curve is still 2x square minus kxy plus 2 equals 0. So now we have to decide that for what range of k, what values of the k, these two will have no point of intersection. Okay, again I will substitute this over here. So it will become 2x squared minus kx into y is 4x plus 3 and plus 2 equals 0. Let's simplify it a little bit. 2x squared minus 4kx squared and plus minus minus 3ax plus 2 equals 0. I can write it as 2 minus 4k into x squared minus 3kx plus 2 equals 0. Okay, now how can I find the, let's see, sorry. So let's just try to solve this thing for the values of x. Again, using quadratic formula, x equals minus b. So it is going to be 3k plus minus under the root b squared. So it is 9k squared minus 4 and a is 2 minus 4k minus 4a and c is 2 and divided by 2a. So that is 2 times 2 minus 4k. Okay. Now, if this have a real value, if the solution of this thing is a real number, right? So that means there's a point of it. We found the point of intersection, right? But if this is a complex number, okay, then we can say that there's no real solution exists, and the point of intersection is not. There's no point of intersection. So it will have real a complex solution only if this is discriminant means this 9k square minus 4 times 2 minus 4k times 2 if this thing is less than 0, right? If it is less than 0, then there's no solution, right? There's no point of intersection. Okay, so let's simplify this expression. This is 9k squared minus 8 plus 16k. Oh, I see. Oh, there's a 2 as well. Okay, sorry. Let me do it again. This is 9k squared minus, I can make it 8. 8 into minus 4k. And let's solve it for 0. And then we write. Okay, so this is 9k squared minus 16 plus 32k 0, so 9k squared plus 32k minus 16 equals 0. Okay, again it's a quadratic expression. Let's solve for k. So k is equal to minus b plus minus under the root b squared minus 4a and c is minus 16, so it will become plus, and it is 16 and divided by 2a. So that is going to be 18, right? And when we solve this thing, it gave us two solutions, 4 by 9 and minus 4. Okay. Now you can see that this expression, this quadratic expression, it looks like a parabola opening up. Okay. So it's a parabola opening up, and the 2 point of intersection are, this is 4 by 9, and this is minus 4, this point, right? So if, and this is the value of k, right? So if k is between these two values, this whole discriminant is going to be negative, okay? And when it is negative, then there is no real solution for this one. So the range of k, which will give us no intersection, it is from minus 4 to 4 over 9. Okay, I hope you understand the whole logic of this problem, like how we decided what these values, this range. Okay. Uh, okay, so let's move on to question number 7. Okay, the equation of a curve is this. A point P is moving along the curve in such a way that its x-coordinate is decreasing. Okay, so we are given this expression, and we are also given that that its y coordinate is decreasing. So dy by dt, okay, because it represents 5 units per second. So the rate of change of y with respect to time, and it is decreasing, so it's minus 5, right? Okay, and you can see if I differentiate this expression, uh, this is y equals 4x squared plus 9x power minus 2 minus 8. So the dy by dx is equal to 8x uh, minus 18 x power minus 3. So it will become 8x minus 18 over x power 3, right? And what we need to find out, you see, find the rate at which the x coordinate is changing. So we need to find dx by dt. This we need to find out at x equal to 2. Okay, so you can see that dx by dt, using chain rule, it is dx by dy into dy by dt. Okay, now dy by dx can be written as, if I make x cube common in a denominator, it will become 8x power 4 minus 18, right? So dx by dy is going to be the reciprocal of this one. So it is x cube over 8x power 4 minus 18 into dy by dt, which is minus 5. Okay. Now we need to find the value of dx by dt when x is 2, right? So this is going to be 2 to the power 3 into minus 5, okay, divided by 8, and 2 to the power 4 and minus 18, okay. And when we calculated all these things, it came out to be minus 4 over 11, okay, minus 4 over 11. Okay, so find the rate with the, yeah, so many units per second. Okay, so this was easy, part A. Now part B says find the coordinates of the stationary points of the curve and determine its nature. Okay, so again, the curve is given as y equals 4x squared plus 9 over x squared minus 8. Let me make sure. Yes, 9 over x squared. Okay. So how can we find the stationary point? We will differentiate it and put it equal to 0. So we already found dy by dx and that was 8x power 4 minus 18 over x power 2, right? Let me, oh, 2 or 3, 3, yes, sorry. This is x power 3. Okay, let me make sure it is 4, 8x4 minus 18. Okay, yes. So, and in order to find the stationary point, we have to put it equal to 0. So from here you can see that 8x power 4 minus 18 has to be 0. So this is x power 4. So x power 4 has to be 18 over 8, which is 9 over 4. So when I take the square root on both sides, so x square would be plus minus and 3 over 2. And when I take further square root, so x is going to be, if it is positive, the answer will be plus minus under root 3 by 2. And when it is negative, the answer is going to be plus minus iota under root 3 by 2. Right? So this was x power 4 is known. So x will have 4 answers, 4 roots. Right? But of course, we are talking about real numbers, real roots. So we will not consider these two. Okay, we will consider only these two roots. Okay, so when x is this, find the coordinates of the observation point. Okay, so let's try to find the value of y now. So y is equal to 4 and x square is this number, right? Mhm. Okay, so it means we are considering only the positive value of x square, not the negative value. So when x square is positive, it is going to be 4 and 3 by 2 plus 9 into 2 by 3 and minus 8. So it is 6 plus 6 minus 8. So 12 minus 8 is 4, right? Uh, so the stationary points we have is x is 3 by 2 under the root and y is 4. This is one stationary point, and the other stationary point is minus under root 3 by 2 and 4 again. Okay. Um, okay. Now, um, okay. Now, whether we have to determine whether these points are minimas or maximas, right? So for that, I will differentiate it second time. Remember, this dy by dx can also be written as dy by dx can be written as 8x minus 18 over x power 3. So it is easy to differentiate now. Second derivative, d square y by dx square, it is equal to 8 minus, and this is x power minus 3. So it is plus 18 times 3 over x power 4. So it is 8 plus 54 over x power 4, right? And 54 over x power 4. Okay, now you can see that when I put x power 4 was equal to 9 over 4, right? So x power 4 is 9 over 4. So when I put 9 over 4, this will be a positive number. Okay, so this second derivative is positive for both values, right? So it means this was a minimum point. Okay, because at minimum, you see, when the function has a minimum point, so the derivative, the second derivative is the rate of change of the slope, right? So slope is 0 and it is increasing here. Okay. Um, so it is positive. The rate of change of slope is positive, right? So when the rate of change of slope is positive, when the second derivative is positive, it means that they have the minimum point. So the points are minimum. Okay. So this was the second part of this problem. Now let's do the third problem. Okay, this is very interesting, bit complicated. We are given the equation of a circle and a straight line. Okay, so you can imagine that this is something like a circle is this, and there is a straight line like this. Let's say this is my y-axis, you can imagine. Okay, so this line is x equal to -2, and it has two intersecting points on the circle. Okay, so first of all, we need to find the two intersecting points. Okay, so how can we do that? Uh, I will substitute x equal to -2 in the equation of the circle. So when x is equal to -2, x squared is going to be 4 plus y squared minus 6 into x is -2 uh, plus 10y minus 27 equals 0. So this is going to be y squared and plus 10y. Now I have, you can see 4 plus 12, right? And then minus 27. So this all gives me 11. Minus 11 equals 0. Okay, so y equals minus b plus minus under the root b squared minus 4a into c is minus 11 divided by 2a. Okay, so when we simplified this thing, it gave me two answers, which are 1 and minus 11. Okay, so the two intersecting points are, one point is -2 and 1, and the other point is -2 and minus 11. Okay, uh, find the area of the triangle. Okay, so this was easy. Okay, now the second part is that we need to find the tangent line to this curve and tangent line at this point basically. We need to find the two straight lines which are tangent to the circle at these points, right? And then we need to find the area of this triangle. Okay, so how can I find the equation of this straight line and equation of this straight line? Okay, so what are the slopes of the tangent line at the point of intersection? In order to find the slopes of the tangent line, we need to differentiate this expression of circle. So this is implicit definition. The derivative of x squared is 2x, but derivative of y squared is going to be 2y into dy by dx. I hope you know this topic. Okay, minus derivative of 6x is 6, and derivative of 10y is going to be plus 10 into dy by dx. And derivative of 27 is 0, so this is equal to 0. So if I take dy by dx common outside, inside I will have 2y plus 10. And the right side I will have 6 and minus 2x. So from here you can see that dy by dx is going to be 6 minus 2x over 10 plus 2y. I can divide it by 2 to make it a little simple. So this is 3 minus x over 10 plus y. Okay. 3 minus x, and sorry, not 10 but 5. My mistake. I will erase this thing. Okay, and make it 5. Okay, now let's try to find the derivative dy by dx at this point, which is minus 2 and 1. So 3 minus x is minus 2 and 5 and y is plus 1. So this is going to be 5 by 6. Okay, this is 5 by 6. Similarly, dy by dx at minus 2 and minus 11, it is going to be 3 and minus x mean plus 2 and 5 minus 11. So it's going to be 5 over minus 6. Okay, so 5 by 6 and minus 5 by 6. These are the two slopes. Okay, now I need to find the equation of this straight line. Okay, so you know the equation of a straight line when we know the one point and the slope. It is given by, we should write, let me write it in red to remind you that this is not the, okay, so it is, yes, y minus y1 equals mx minus x1. Okay, x1, y1 is the coordinates of the point, known point, and m is the slope. Okay, so go back. Okay, so equation of this straight line is going to be y minus y1, which is 1, equals m, slope 5 by 6, and x minus x1, so x plus 2. Okay, so this is one equation, and I can simplify it a little bit. Y equals 5 by 6, x plus 2, and plus 1. And the second equation using the same logic is y minus y1 is 11, so plus 11 equals slope is minus 5 by 6, and x minus x1 is again x plus 2. Okay, so these are the two equations of our straight line. Now the next thing is that where are these two equations intersecting? Okay, so I can write it as y equals minus 5 by 6, x plus 2, and minus 11. Okay, so these are the two equations of those straight lines, or two tangent line basically. These two lines are the tangent to the circle at the point of intersection. Okay, now what is next? Now I want to find the intersection point. So I will have to solve these two equations. So let me put them together equal to each other because they are equal to y, both of them. So it is going to be 5 by 6 x plus 2 plus 1 is equal to minus 5 by 6 x plus 2 minus 11. Okay, so how can we simplify it? So this is going to be 5 by 6x, and this is minus 5 by 6. I will go on the other side, it will become plus 5 by 6x. Okay, on the right side, I have minus 5 by 3 when I multiply this with this, right? Similarly, here I have 5 by 3, it will become minus here, minus 5 by 3. And I have minus 11 here and minus 1 here. Okay, so the next step, it will become 10 over 6 x on the left side, and the right side is minus 10 over 3 and minus 12. Okay, so uh, you can see that this is solved as x equal to um, I hope I'm doing it right, minus 46 by 5. Okay, and when I substitute this value in any one of the equations to find the value of y, so you can use this equation. So y is equal to 5 by 6, and x 2 plus x is 2 minus 46 by 5 and plus 1. And when I simplified this whole thing, it gave me minus 5. Okay. Okay, so now we are in a much better situation. We have this triangle, something like this. Remember, this point was minus 2 and 1. And this point was minus 2 and minus 11. And this third point of intersection, this comes out to be minus 46 by 5, and x is this and y is minus 5. Okay, I hope you understand what I'm doing. Basically, this triangle is this triangle, which is formed by these 2 points of intersection, and the intersection of the tangent line, this point. Okay, so I am showing this triangle in an isolated form. Okay, and now the final thing is that we need to find the area of this triangle. Okay, it is not that difficult because you see this is a vertical line. Okay, and so in order to find the area, I will do half and base. I will take this distance as my base. Okay, how much is this distance? You see, this is 11 and 1, so this is 12 only. Okay, so I will take my base as 12, and altitude I will take this distance. Okay, and how much is this distance? Uh, this is minus 46 by 5, and okay, no, from here I will take minus 2. Okay, uh, this is my what altitude, I can say, right? So let's calculate this thing quickly. 46 divided by 5 and minus 2. This is 7.2. Okay, so this length is 7.2. So I have to just multiply this thing with 7.2. Okay, so this whole thing comes out to be 43.2. Okay, this is the area of this triangle. Okay, I hope you enjoyed this question. This was very a bit challenging, and I think about a lot of things. So, yeah. Okay, thank you very much for watching. Uh, I will appreciate if you can subscribe my channel. This will be a big help for me. Thank you for watching. See you in the next video.